So now here I am trying to solve a problem from book Puri. It's a solved example of the solved problem in that book. It's a very good problem. So here a classical electron moving in circular orbit around a proton. Now we have to derive the differential equation for the electron energy and taking into account the classical radiation laws, and on the basis of that we have to calculate that when it is radiating energy continuously, that means it is coming closer towards the proton because it is revolving around the proton, and a stage will be reached, it fall into the first Bohr orbit and finally into the nuclei or proton, or collapse into the proton. So what we are interested to find out the energy. We are interested to find out the time when it will fall into the first Bohr orbit. So situation is like this. Say here it is a proton, and around this far away an electron is revolving, and see it is radiating energy, so its path is not exactly circular. So slowly and steadily, while it is radiating energy classically, so it's slowly and steadily moving towards, and say it is the first Bohr orbit, let us assume that, and we have to calculate from here to here how much time it will take time to fall into the first Bohr orbit. So let us proceed for this. Now the rate at which energy radiated by an accelerated electron, so it is represented as 2a square e square 3c cube. Now the total energy is nothing but it is the sum of the kinetic energy plus potential energy, and it is half mu square plus e square by r. It is the potential energy. So what I will do, the negative sign is there, right? Now for circular motion, is the ma is the centripetal acceleration. This balances this energy, centripetal, so it is minus e square by r. This force is nothing but negative of the potential gradient. It's a gradient, so that's why it is d upon dr. So it is simply e square by r square. So therefore, this centripetal acceleration from this equation of motion, it is e square over mr square. But centripetal acceleration is, we know from the basic definition, that is e square by r. So that means if I compare these two terms, then what I am getting, u square by 2, not 2 but r, it is equal to e square over mr square, and from here half mu square is nothing but is equal to 1 by 2 e square by r. So keeping this in mind, this equation will reduces to, for e, this e is equal to half mu square minus e square by r. So I will substitute its value from here. So it will become it is half E square upon R minus E square by R. So it is E square minus 2E square upon R. So it is finally minus E square by 2R square. So therefore, dE upon dt means the radiation loss for the electron proton system. It is d upon dr minus E square by 2R and is equal to minus d upon dr E square by 2R. It can be taken outside. So it is minus E square by 2 and 1 by R is there and its differential will be 1 by R, but R is further function of time, so I will writing it as dr by dt because R is changing with time. So it is E square over 2R square and dr upon dt. So therefore, what I am getting minus dE upon dr is equal to, as I know from earlier, or from the beginning of this problem, it is 2a square E square by 3c cube. So therefore, comparing these two results, this and this, because both are equivalent. So if these both are equivalent, so that means minus E square over 2R square dr by dt is equal to 2a square E square over 3c cube, and this E square will cancel out with it. So it is dr over dt is equal to, this goes towards that side with negative sign, so it is minus 4e raised to power 4 sorry, minus 4a square over 3c cube. It is equal to minus 4 over 3c square, and the value of a will be e square over mr square, and r square is again there. This r square can change. dr by dt is equal to minus 4e raised to power 4 upon 3m square. R raised to power, this 1 r square will cancel out with it, so it is 3m square r square c cube. So now dt can be written as minus m square c cube 3c 3r square upon 4e square and dr. So therefore dt is equal to minus m square c cube over 4e square and 3r square. If I want to calculate the total time, 0 to t, means I have to take the integral of this 0 to a naught, means it will take capital T time to fall into the first Bohr orbit. And here, if I talk in terms of r, then that means it is taking it is moving from a distance capital R to a naught, and a naught is the Bohr radius. Then this integral limit will change. So this will change, means I have to integrate this from R to a naught to R, and this is from 0 to t. So finally, m square c cube 4e square, sorry, not 4e square but 4e raised to power 4 is there. Let me correct it. Yeah, because e raised to power 4 is there, that's why it's 4e raised to power 4, and it is 3 r cubed by 3. This will cancel out with it, and I will take the integration limit from r to a naught. So it is equal to minus m square c cube 4e raised to power 4 and r cube minus, sorry, a naught upper limit minus lower limit, right? So if I take negative from here, then this negative sign will cancel out. So finally, this t is equal to m square c cube over 4e raised to power 4. It is r cube minus a naught cube, right? So this is the time it will take to fall into the first Bohr radius. So with this, the problem is solved. And thanks for watching this video.